All right. So we're going to continue to review some of the basics of Python programming. And so today we're going to look at strings, basic file I/O, and also the lists and dictionaries. These are some of the basic types in Python. Okay. So first of all, for strings, we have seen some very primitive data types such as integers and floating point numbers. So those are primitive types. They are fundamental. They don't really have additional parts to them. They're just, single values. However, a string is a little different. A string, it's kind of a data structure in the sense that it consists of smaller pieces of data. In many languages, actually, the structure of a string is, typically can be represented like an array, although in Python, we don't really have the concept of array, but there is also array data structure in the array library. But we're not going to talk about array. We're going to talk about string right now. And the string is, if your memory could be seen like this, if you have this high there, this is a literal string. So you see this is represented in a sequence of characters. You have this, each character occupies, in this case, occupies a byte. But this is the details of how many bytes a character occupies. That depends on whether it's a Unicode and how that Unicode is represented. So for now, we're going to look at basically these are the English characters. They're simply just 1 byte. But the details of that is not that important. But the idea is this string, each character in the string can be identified with the index. You see this starts from 0, and you have 1, 2, and so on. And the length of that string can be queried with the function len. And so the len function can be used to query the length of a string, also many other data structures and many other objects that has some kind of structure that, has a concept of a length, such as, the number of items. And the length of an empty string obviously is 0. So how do you access the individual parts of a string? You can use the subscript operator with the square brackets. Inside the square bracket, you have this an expression that evaluates to a number, which is the index. And so with this syntax, here's an example. You have this literal string, Alan Turing, name, subscript 0. This is basically the first character, which is capital A. And then, of course, subscript, 3 at index 3, that would be 0, 1, 2, 3. That's letter N. Now, if let's say we know the length of the string is, you can use the length function to get the length of the string. And then this length is not a valid index. Actually, this is just beyond the valid index. The index is from 0 to the length minus 1. And so the length of name, if you want to query that as index, and this is going to give you an error, actually will throw an index error exception right here. It tells you index out of range. So the last character is really the length of the string minus 1, because it's 0 based, starts from 0. The count of index does not start from 1, so it starts from 0. And in Python, you can actually use a negative index, which is actually shorthand for the length of the string minus 1 in this case. If the index is a -1, it's equivalent to the length minus 1. So length minus 1 is the last character, right? So -2 would be you count backwards. -2 will be -1, -2, that's the letter N, okay? So the subscript operator as defined on a string is the mechanism for you can access to the individual characters, and also you can this actually we're going to see some other objects. This we can use the same operator on those objects, but they have different meaning. So in fact, if you define your own type, you can actually implement the behavior of a subscript operator if you want to for your own data type. But this is the built-in type string. Here's another example. You may use a for loop to access every character in a sequence. And the idea to do that, this is actually just one way. We're going to actually see another way just in a bit. One way is to use the range. The range is a class, by the way, and this is making a range object. And the range object, so if we're only providing a single argument here, this is the stop argument, right? So it starts from 0 by default, and it stops at this, the length. And then we know the stop index is not included. So basically it starts from 0 to length -1. So that's basically the whole range of the characters, the indexes on the string. So this is one way to do it, all right? So it works, okay? Now, when you have a string, if you can't modify or get anything out of it, it's kind of not very useful. And here's the thing to remember though, the string object is immutable. So when you have a string object, the object itself cannot be modified. However, you can make new objects out of it. For example, a very typical operation is you want to get a portion of that string. So the mechanism to get a portion of a string, or called substrings, is by using slicing. So we use this syntax here. So it's easy to look at the example here. Now, this actually has a fairly interesting correspondence with the range class. The way to make a range object, it takes start, stop, and a step, right? 3 optional arguments. And in fact, you can use the slicing expressions and with this colon in the middle actually just corresponds to that pretty much. So, so you have a first colon, the first number before the first colon, that is the start index at 0. And then the number after the colon is omitted. That will be basically the length of the string. Okay, so this will give you actually the whole string. And in fact, it's just equivalent to making a copy. So of course you can specify the stop with the second argument here for this slicing expression here as an index. So if you say 0, from 0 to 1, that means just 0, not including 1. In fact, the stop is telling you how many characters in total. If the first index is 0. So if from 0 to 1, it just, if this is only the first character, if it's 0 to 2, then the first 2 characters. If you omit the first argument to this slicing expression here, that would be 0 by default. So this is obviously giving you the entire string equivalent to the first one we saw. So the first one we omitted the stop index, here we omitted start index. So you can also use negative index. Now, remember the negative index -3, this really means length -3. Then we're omitting the stop, which is, by default, length. So this basically means the last 3 characters will be printed out. Okay, so this is a various examples. And of course, you can be getting a piece of a string in the middle, let's say from 2 to 6. Okay, so we have 4 characters. So the stop minus start, you have 4. So in total, you have 4 characters, starts at 2, not including 6. So you have a 2, 3, 4, 5. The characters corresponding to those indices. Another common operation, obviously, to test if a substring is part of a string. And you can use the operator in operator, that what you saw in the for loops we've seen so far, that in is like an operator. But in the for loop, it's the meaning is a little different. But if you just use this as an expression, you can test if something is in the string. For example, if we're gonna, let's actually take a look at, okay. So let's say we're on Python 3, and let's say we have a string hello, and then let's see if the H in A, it says true, right? So that means now if we say, okay, LL, ELL in A, that's also true. This is because it's a substring of A, of hello, right? So this is the in operator. This is a Boolean expression. So this, you can use this to test if a substring is part of a string, all right? Now, of course, this is an example here. We have, let's say we have a list. We're gonna see more details about list later on. We have a list of 3 strings. And then we loop through that with for this typical for loop. All right, and here we're using the in operator to test if this file name contains .txt, then we'll print out the file name. Now, keep in mind though, this substring could occur anywhere in that string. It may not be in the very end. So string has many methods you can use. We've seen some typical operations here so far with operators, specifically subscript or slicing. Now, a string is a class. It's a built-in class. A class has methods, like what you can do about this, the objects of such class. So one example is you can split a string by a certain delimiter. And if you don't pass the argument here, by default, it will split by white space. So essentially, you can break a sentence into a list of words. They're broken down by spaces, so you're going to get a list of words. And you can obviously count how many characters there are. And so this is just a simple example to do some calculation. But the idea here is the string, you can split it based on a delimiter. So generally speaking, a method invocation is this typical format. So you have an object, which is the variable name, or just a plain object. Okay, could be a literal. Either way, and then you can call the method on it with a dot notation here. And this is the name of the method, such as a split. And then that method takes arguments. It's like a function call, but the function is bound to this object. And basically that function is to be defined for the class that this object belongs to for this to be valid. So it's not a free function. This is a function belonging to a class, and which is called a method. Otherwise, they are very much the same as functions. Now, of course, the methods can take arguments and return values. And the method, when it's defined for a class, the first argument it takes is the object itself. And so that it will manipulate, read or write the state of that object, basically the attributes that comprise of that, basically that's a part of the object. You can modify that. That's called the state of the object. Now we know in Python, everything is called an object, including the function definition or class definition. Those things are also objects. And if you want to query, this is just through the interactive program of a Python. You can query the methods by calling the dir method. So here's an example. So dir string. Okay, so you get a list of the methods that are available. Okay. And then you can also actually query, the documentation about a particular method, for example, the split with the help function. This is a sort of terminal-based way of looking up the documentation, but typically I would recommend you go into the Python reference itself for much more comprehensive documentation. So this is basically from the Python official website. And then they have a search box. You can search for, let's say string.split. Click on that. So you have actually a lot more detail, including examples. So that's what I would recommend you to look up the documentation when you want to, check how to, just some more details, how to use a certain function or what's available on a particular type. Now, your IDE should also offer you the help. Like if you just hover over, a name of a function, for example, it will show you the documentation and the syntax. So it's very convenient, but this is a summary of what you can do. So it's quick. And this is typically how you probably would just do that quickly while you're coding, but then you're studying something in details, you can look at the official documentation on python.org, right? And then, of course, when you're splitting a string, you can pass a delimiter, which may be a single character, maybe multiple characters, just as some string. So you can split based on that. So for example, my file.txt, if you split on dot, you get a list of 2 strings. Okay. Now, how do we deal with the files? So of course, files is essential. I mean, your operating system has a file system, and your documents, while you're working on something, you have those things stored locally, and your programs that you run, they all in form of files. That's when you actually write a Python program, it's also put into a file, right? So of course, a general programming language like a Python has the mechanism to deal with the files. So in Python, the primary function to deal with a file is this open function. So you can open a file, given a file name, you pass in the mode. This mode W here means to write into the file. When you use it this way, it's going to actually open this file. If the file exists, it's going to truncate it first. And then you can write new content into it. For example, this, you write a string to it with the write function, or actually the write method. And then you wonder what would be the object for F. Now, the object for F depends on your mode. And by default, it's going to be a text-based file. So the object that's returned by this open function is actually an object of text IO wrapper. So you can actually look it up if you, let's go to text IO wrapper. So it's in this IO library. This is actually the class. You can actually check the object of F by using the type function. Just type parentheses F. You'll see the type that will be shown to you. Now, so this has actually a lot of good documentation. If you're interested, you can read into this. And there's actually a class hierarchy of different classes that deal with IO. And so anyway, we're gonna just look at the simple scenarios here. And this is how you open a file to write something to it. And then in the end, you may consider closing the file by calling the close method. Well, this mechanism of calling the close method is kind of a little outdated, and a more typical way of opening the file, you do something, then you make sure it's closed, whether the operation succeeds or not. Maybe whatever you're doing with the file, some exception is thrown, and then you have to make sure that close is called. Although it's not the end of the world if the close is not called, because Python is going to do, it has this garbage collection. It's going to actually close the file at some point, although you don't know when. Okay, but it's actually a good idea to make sure that file handle is closed. And we're going to see an example, actually. Well, I'll show you example how, the better way to do it. So here's an example. In the old days that if you call the close, now here's the problem though. You open the file right here. You do something with the file. What happens if this throws an error? And this close will never be called, right? So this is actually not a good way of doing it. Of course, you can correct this with a try finally clause, right, for exception handling. And the alternative way is to use the with statement. Okay, the with statement, you'll see an example. I'll show you right away. Let's get through a couple more slides. Now, how do you read it? If you read a file by using the R mode. This is the sort of string that indicates what are you trying to do with the file. So you may open a file for reading with a character R here. And there are more options right here, but just good enough for now to know the basics. Now you can read the entire content of the file with this read method. And then it gives you that content as a string. Now, you may also want to read the file line by line. So you can actually use the file in a for loop. The file object, you put this in the for loop, and then basically is iterating the file in terms of consider the file as a list of lines. So it's separated by lines, and so each iteration, it gets a line from the file. So this is line-based processing here. Now, this is one way to do it. You can iterate through that file with this for loop. If you want to use a while loop for whatever reason, and then you can call read line method on the file object. And that also gives you a line. And then it's just an alternative way of iterating through the file. Same thing, okay? So these are some of the basic methods on a file that you have seen so far. Now, open is a free function, and depending on the mode, it may give you different objects. Now, with the text-based files, you get typically text IO wrapper objects. And then you can close a file with a close method. You can write a string to it. You can read the whole content, or you can read line by line. So let's take a look at an example first. Right. So let's say we have a payroll report. Actually, this well, the payroll report is very basic. Let's see. So we have a text file like this. It has 3 lines of data, and each line you have a name, which is the name of the employee, and then you have the hourly wage, and then you have the number of hours worked. So suppose this is the format of the file, and in this kind of tabular format, and I want to process it. So here's an example of using the with statement. So you do this with, and then here, now this can be extracted out into its own statement if you want, right? This returns the file object. Now, inside the open, we actually put in the input function here to get the file name from terminal input, okay? So we're kind of put a couple of actions in the same statement. For readability, sometimes it's better to actually have a separate statements for those things. Okay, so we're going to read this code and we're going to run it. And then what you do is, this is a file object. If you write this as a separate, let's say if you do this, a separate statement, this is the same thing. Okay. Well, I take it back. It's not the same thing. In fact, you may take the file name out of it, right? And then you have to open in here in the with statement, so that the this is kind of the typical way of doing it. Basically, you're actually assigning the result of that, which is a file object. You're giving a name like this. So this is a instead of the typical assignment, what you have here is you using this with statement. This is basically the format here. This is the syntax. Okay. And then we're going to actually print a header about name, hours, and total pay. And then we're going to print out each row. We're going to print out the name and the hours and also total pay. The total pay is the hours times pay rate. And so as you see, examples that we have seen last lecture is the F strings. We use F strings to do the string formatting here. Okay, so if we're going to run this, and I'm going to put in the path to the file. Okay, so it prints out that table. Okay, name, hours, and total pay. Right? Now, you may have not noticed any difference, like, okay, what point does the close? Actually, this with statement, as soon as this statement is finished, it will call the close method on this file object. All right. So by doing this way, even if the inside block fails, it will still gonna call the close. So that's guaranteed. That's kind of the logic. This is the alternative to the try finally method. Okay. All right. Let's take a look at the lists and dictionaries. These are fundamental data types. A list is a sequence of data values, and they are typically arranged in memory contiguously. They are not what you may have studied data structure list. Linked list is not linked list. It's more like the array in other languages. However, this is a more of a dynamic array, is able to expand as needed when you add more data to the list. So in some languages, for example, in C++, the equivalent class to this list in Python would be vector. And then in Java, you have array list. That's more like where you see the list here in Python. So of course, there's many examples of lists. And in fact, the Python list allow you to have mixed types. You may have a list of integer together with a string, together with the floating numbers, floating point numbers. So you can do that. However, not very good idea if you have lists. It's a good idea to have a list of the same type, although you're allowed to have mixed types. Now, of course, each item in the list has a unique index. This is just like what we just saw, the string. string is a sequence of characters. So they're very much similar in terms of what you can do with it. So the index also goes from 0 to the length minus 1. So here's a list, how you declare a list in literal. This is a literal list by using the square bracket syntax, and the items are separated by commas. You may have nested lists. This is a list of lists. So this allows you to do sort of a multi-dimensional array in a way. Now here's an example of a mixed type. Actually, this list here, first element is an int, second element would be a float. So this is allowed, but in terms of, I guess this is okay in this case. Depends on what you're trying to do. Typically, you want to use the same type. Now you can create a list out of any iterable object, and a range object is iterable. Now iterable means that class needs to implement this special method __iter __. So that's kind of the technical details behind, but so this built-in range object supports it. So you can create a list out of a range. You can also create a list out of a string, because a string is also iterable. And so what you get is a list of characters in that string. So the operators or the functions that we saw with a string, they're going to work with the list as well. So previously, the length of a string is the number of characters, because a string is a sequence of characters. And then you can do a length of a list, that's the number of items in the list. And then the array, the subscript operator works the same way on a string as on a list. For example, if you just pass in a single number here, this index is 0, that means it gives you the 0th element. That's the first element. And then you can use the slicing operator to get a sort of a range out of that list. So this will give you a sublist of 2 elements from index 2 and 3, not including 4. Remember, this is a start and a stop index. So you get a subs list out of it, like how you get a substring out of a string. Concatenation also works on string, on list. So we saw how it works on a string, because they're very similar, except the string is a special type of list in a way. It's special because, well, first of all, it's immutable, and then also it only works with the characters. But list is a more general type, allows you to hold any kind of data. So if you have a list, let's say first, which is 3 and 4, actually 1, 2, 3, 4, I believe. And then you concatenate with another list, 5, 6, and then you get this combined in that order. You can compare if the two lists are equal structurally. This is structurally, are they equal? It will compare element by element. If they're the same, then the result is true. You can print out the content of the list. So the print function will work on that. And then you can check for membership. we're using the int operator, just like in a string. You can check if a substring is part of a string. You can also check if element is part of a list. So check if 3 is in this list and 0 is not in this list. And then you can modify the list, of course. The list is immutable. So you can insert, remove, or replace the elements. Now, so here's an example. You have 1, 2, 3, 4, a list of 4 integers. And then example, subscript 3 has basically the third, well, actually 1, 2, 3, 0, 1, 2, 3. It will be the last element in this list. And then we're changing the value of that item to 0. So you end up with 1, 2, 3, 0 here. Okay. So you put that expression on the left-hand side. Now you cannot modify a string so that you will not see a usage like this, but you can modify a list. Now, just a more example of a mutation on a list. And say you start with the numbers 2, 3, 4, 5 as a list. And then you can loop through that list using the range function. And range, now this is basically what iterating through the indexes of that list by using this method that we've seen before, how we use on a string to iterate through the characters of a string. So this is a similar idea. You get an index, and then now here we're modifying the elements. And actually here we're using a augmented assignment for the exponentiation, right? So every element now becomes to, we actually multiply that with itself. Basically, we're using the power of 2. So you have 2, 3, 4, 5 becomes 4, 9, 16, 25. So the split, recall the split method on the string. It gives you a list of strings. And here I'm showing you a different way of looping through a list, while you also may want to modify the content. So you use the enumerate function. And by doing that, you're getting some kind of an enumeration object, and that supports iteration. And then, in fact, each time it iterates, it will give you actually a tuple. That tuple has 2 values. The first one is the index. The second one is the actual value for that element. So we need that index to modify the value. So here we are using the indexed, with the subscript operator on the left-hand side of the assignment. And then we're making some modification. We're saying, well, let's change the word to uppercase. And then put that uppercase word into that position. So we're modifying everything. Now they're all caps. So there are actually other methods you can use on a list. So here's a partial list of what you can do. You can use the append method to add an element to the list. Then you can also call extend. The extend, you're actually concatenating with a different list. So although we have seen we can just use the plus operator, probably more intuitive, but you can use extend. We can also insert an element at a specified index. You can also remove the last element. It's called a pop. And you may also remove an element from a particular index. That's the pop given an index. So here's some example about inserts. So you have start with this list of 1, 2. We're inserting at index 1 for a value 10. So index 1 is, okay, we're not touching 0. That's 1. So we're going to put 10 at the index position 1. And the original, whatever is remaining, got pushed to the right. So 2, it goes after. So the index position 1 is 10 now. So whatever was there has to be moved to the right. And it may insert at index position 3. This essentially basically just add an element to the very end. All right. So 0, 1, 2, and then 3 goes to the very end. Actually, let's try this. So you have an example, 1, 2, let's say 1, 2, 3. Insert 3, 4. Okay. All right. So actually, let's try what happens if we do okay, now 0, 1, 2, 3. What if we do 5? Okay, it doesn't matter. You see what happens here, because the what you're trying to insert, it's already greater than the length, and it will essentially add this to the very end. So maybe a little surprising, but it's kind of how it works here. All right, here's the example of a append. So if you just want to add element to the very end, you just simply do an append. Sometimes that's all you want to do. You don't care about even the order, so you just append to it. The extend is the same as the concatenation. See that? You just concatenate. You combine into list into a new list. Keep in mind that when you use this, you're not modifying the existing list. You are getting a new list. However, when you do the extend, you are modifying the existing list. So that's the difference here. So you can remove element with a pop. So here, if you pop it, it's simply just removing the very last element. You can pop an element at a specified position. So let's say you're popping the index 0, and then you're basically removing the first element. So what you have is what's remaining. How do you search in a list? So to search in a list, first of all, the in operator still can be used to check if an element exists or not. It's very much like how you do this with a string. So here's an example. If you want to check if a 45 is in this list, and then we do something. If it's not in the list, we do something else. Okay, so in this case, obviously it's going to be true. 45 is in the list. And the list can be sorted. So you can call this a sort method. to sort. In this case, you're going to sort this in an ascending order. So 2, 4, 8, 10. Now, you can sort it by different order, even different mechanism of comparing the elements. So you can pass additional arguments to the sort method. So you can look into the documentation to see what's available. So the methods that actually modify the list itself, they are called mutator methods, like such as insert, append, extend, pop, and sort. They're actually going to change the list object itself. So they're called the mutator methods. The methods that are not mutating, they're typically called accessors. Or performing some arbitrary operation. So the mutator, like a sort, is actually a mutator here. It will sort the elements in place. So your list object will be modified by doing this. And because it is sorts in place, it actually does not return a new list. In fact, it doesn't return a value. Because it doesn't return a value, Python actually will return something called a none, which is a special value. It has its own type called a none type. Like in some other languages, they call it null, like something that doesn't have a value, doesn't exist, or absence of a value. So if you actually print out, if you want to, this is not, you're getting a none value out of it because the sort actually doesn't return. Now, something to keep in mind about the lists. So some people get confused because in some other language, the behavior is kind of different. Now, this assignment here is essentially saying you have a reference called first that points to this list object. So here's the illustration on the right. Notice that arrow here. It's like it's a referencing this object somewhere in memory. And then you may also have, let's say we're going to have another reference called second. And that second is initialized to be the same value as first. So second also points to the same location as a reference. So if you modify the list through first, then second is not going to see the same changes as well because the same object is getting modified. And then you can access them through both references or variables. Now, what if you actually don't want that behavior? Then you actually need to make a copy of the list. Now, this is one way to make a copy, by the way, but not necessarily the only way. So you can use a for loop, obviously, that we have seen so far, and then you can create a new empty list. And then you just call the append to add a new element to this list. So you build up the same, with the same content. You're copying the list from first now into third. Now third will have its own list object. So this is a copy. Now recall that slice operator, the slicing operator we use to get a sublist. So you can actually use the slicing operator to create a copy as well. So for example, so we have an example here. This is 1, 2, 3, 4, 5. So you can actually just slice it with the defaults, right? Because default will give you the whole list. So what you're getting actually is a new object. Now, for example, to prove this is a new object, so we'll do a slice Now we're going to modify the first element to something different, let's say 100, all right? If this modifies the example object, then we should see example, the first element of example would be 100. Okay, let's see what the example is. It's not changed, right? See what happened here? It's not changed because the slicing operation here creates a new list. Okay, so effectively by using this, you're creating a copy. So that seems a little easier than this for loop. So we have seen the this equality operator before, and we can use this to check the two lists if they are equal. What does equal mean here? It's really the structural equivalence. Are they structurally equivalent? So you have two lists. It's going to compare, well, are they of the same length? Are every element actually equal? So that's the structural equivalence. Now, if what you want is just saying, you know, you have two names here, are they the same? Then you're talking about the object identity. So remember this. If you want to know if this first and third point into the same object or not, then you can use the is operator, like it first is third as a Boolean expression instead of the equals operator. Okay, this is the sort of two different types of equality. So here's an example right here. By the way, this shows a third way of making a copy. You use this list function here. This is actually, you're constructing a new list from another list. Okay, so as you see in memory, third points to a new list object. Now, first and second, they pointed to the same object. So they have the object identity are the same. So you can say first is, second is a keyword. And then so this is giving you a true. Now first is not third. They pointed to different objects, even though the content is the same. Because is compares the object identity. Are they pointing to the same object in the same location? In fact, it just compares if they're actually in the same location. Now, if you use this, the equals operator like this is comparing the structure. Do they contain the same elements? Like, are the elements equal? Right? So this is the difference here. Now, previously we've seen sort of a usage of a tuple when I illustrated a for loop over. So where you can actually use the enumerate, right? The enumerate function returns actually a tuple. A tuple is like a list, but is immutable. And the way to make a tuple literal, like to write it out as a constant, and then all you do is use the parentheses, and then you have the elements inside like this. Now, if you use the square brackets, that's the list, right? So that's the difference. Tuple is another built-in type. Now, when do you use tuple? Well, tuple is like a like an ad hoc object. Without defining a class, you have just some simple elements you put together that is a structure that you want to, perhaps you want to return. Let's say you want to return multiple values. They're just different pieces of information you want to return from a function. Then you may use a tuple, or you can return an object that can contain, it's a custom type, and then you can contain whatever elements you want to return. So a tuple is convenient in many locations. Now, let's take a look at just the function. We'll talk about function. We're seeing how we use a function from a library. How can you define your own functions? So let's look at the simple ways to define a function. You use this def keyword here. Def, it's short for definition, define, actually. And then it's followed by a function name. And the function has a list of parameters within the parentheses. And here, this square function takes one parameter, x. And then you put a colon, and then with a new line. And actually keep in mind that the indentation is significant. The body of the function has to be indented. So here we actually have a single statement, is the return statement. We return a value. So this returns x multiplied by x. Now this string right here, this is a statement also just is a string. And what's the purpose of this? Doesn't really compute anything, right? Well, the purpose of this is documentation. It's called a doc string because it documents what this function does. You can fetch the doc string at a runtime, but you can make also your tools generate some documentation for your function. Or in the IDE case, if you use the square somewhere else, you hover over the square name, the IDE typically will show you the documentation that you've written here. So this is for programmers. I mean, the program not need this to execute. So this documentation is basically for programmer to programmer, helps you to use the function properly. So the general format of defining a function, you have this def keyword and the function name followed by a parentheses. And within the parentheses, you may have 0 or more parameters. This could be empty. And you have a body, okay? So this is the header of the function followed by the function body. So a parameter is the name used in the function definition. When you call the function, you supply arguments that correspond to the parameters you declare for the function. In some cases, the position of the argument is significant. Some cases they are not. There are actually two types of arguments. There's position arguments, there's a keyword arguments. I'll explain the keyword arguments when we see them. Right now, we're just looking at simple ones. Like, for example, this x here is a positional argument. So when you call square, you provide an argument at position 0, and that corresponds to this. You may have more arguments. Okay. And then we saw the example of return statement. You have return followed by an expression. And this is the value that's returned from the function. If you don't return anything or it has no return statement, and then the Python actually will return a value called none. So this is a little special. In some languages, actually many, they don't just give, there's no value. But here it does return a value, even though you don't return. That value is called none. And here's another example. This is a simple example called checking if a number is an odd number or not. So return x modulo 2, and whether that equals to 1 or not. If it equals to 1, that's odd. Otherwise, it's even. And then here's another, this is doc string. It's not mandatory. If your function is simple enough, you may not need to write this, but if your function is not very intuitive, you don't, again, providing some documentation is recommended. But if you're writing some quick program, you don't necessarily have to write this doc string. And by convention, now Python is a language that operates on conventions. By convention, we may also define a main function. It's not strictly necessary, but it will structure a program better, especially when you have, define a couple of functions. You may want to put your main logic, the entry point of your program, into a main function. So here's an example. Let's say you define a main function. That's where the program is going to start. Well, the program actually starts from here. So the Python interpreter is going to see, okay, you got a definition, another definition of, say, function main, function square. Then it's going to execute this if statement. This if statement, it's checking if the name of the current module, this is a special attribute that's available. And then you check if this equal to main. This is the name that's given to your, if you have this program here, compute square.py. And then the code that's outside of any function, they're in this so-called global scope. And then the module that this program is actually a module. It's going to give a name when you run this as a program. And the name of this module is called a main with underscore on both sides. This is a double underscore, by the way. So if you're executing this file as a program, and then this name will be equal to main. And so you will execute this if statement, and then inside we're going to call this main function here. However, if this program is imported into another program as a module, then this will not be executed. And because the name will be, in this case, will be the name of this file, compute square, in fact, without the extension. So this essentially allows you to run this file as a program individually, or it can be still used as a module elsewhere. When they import this, they want to use something you wrote here. Let's say the square function they want to use. They can import your module without executing everything in the main. That's kind of say this is the code you're testing your program. Okay. Dictionaries is another fundamental type in Python. Now, a dictionary, there's named dictionary because really the analogy is the real life dictionary. You look up a word and then the word has a definition, for example, right? And a dictionary basically has a key, and that key has a value. So essentially, it's a collection of key value pairs. That's the best way to see it, is the key value pairs. Is always a pair, key and a value that are associated together. So this is different from list where you just got values. Here, you also have the keys. Now, in the case of a list, you have indexes. Indices, they are actually, in a way, they're the keys, but they're not flexible. They're only, in that position, they're only integers. However, with a dictionary, you can have keys of different types. And then the way to write to make a dictionary as a literal, you use these curly braces. We're going to see an example right here. Use curly braces. And here we have 2 items or 2 elements. And then each element, you got a key value pair separated by this colon. And then this example, we have the key as a strings, the value also strings. although they can be any type, by the way. So the keys in a dictionary, they can be a data of any hashable type. What's hashable? Well, to put it simply, hashable is that the type we can apply a hash function on this object to generate an integer, and this integer allows you to, this is kind of provides this kind of mapping between the object and an integer. And then if two keys are equal, then their hash values are the same. So the keys in a dictionary must be unique. Okay, just like in a real life dictionary, you're not going to get, it doesn't make sense if you have repeat keys. So that's kind of how it's defined here. Now, the built-in types that are immutable, such as int, float, and string, they are hashable. If you define your own type with a class, that also is considered hashable. So they can be used as keys in a dictionary. However, a list cannot be used as a key. A tuple can, because tuple is immutable. A list is mutable, cannot be used as a key. So how do you modify or add value to a dictionary? So we'll come back to this familiar subscript operator. Now you see this subscript operator has been used on this various different types. So that's kind of the idea. You use the same kind of operator, but then they do different things. Intuitively, you can still understand easily. You can define this for different types. So here's an example. We start with an empty dictionary. By the way, the type name for dictionary is DICT, dict. So by using this statement here, we are putting in a key value pair name equal to Sandy into that dictionary. And then we add another one, occupation, hacker. So when you print out this dictionary, now you got two items. Now you can also use that same syntax to modify, because the occupation was defined, it's already in the dictionary. Now you can provide a different value, and that will overwrite. The existing value will be changed to manager now. Of course, this also allows you to read the current value. If you put this just like in an expression, not on the left-hand side of the assignment. So info name will give you Sandy. Now, if you have a key that doesn't exist, then this is going to give you a key error exception. Now, this in operator can be used to check if a key exists. So we have seen this in operator using all these different types now. Now, just like in list, you can use a pop to remove an entry from this dictionary. So, but you have to provide a key name So you want to remove the entry with a key job. Now, if the job key doesn't exist, you provide a default value. So if the job doesn't exist, it will return none in this case. Well, what's the usage of this? Because if you use this subscript index, subscript operator to get something that doesn't exist, then you get an exception. But by using this, providing a default value using pop, then you're not getting an error here. You will get at your default value if it doesn't exist. So that's the advantage here. In fact, this is for removal. If you want to retrieve the value under a key, then there's another method called get, right? We're going to see some examples soon. How do you traverse a dictionary? Just look through the whole dictionary. You want to do something about it. You can use this for loop as usual. Now, when you for loop through that dictionary, though, you're only getting the keys. You're looping over the key. So you have each iteration, you get a key in that dictionary, and then you can, of course, you can use the subscript operator to get a value based on the key. Or you can look through the items using the items method, and this will give you a tuple of a key value pair. So now you can hold on to the key and the value. So this is just another way to do it. If you supply the dictionary to the list function, this will give you the list of keys. And you may sort it, and then you loop over the keys. Now, this, this does not give you the list of items. This only gives the list of keys. Now, of course, if you want the list of items, then you can call info.get items. The dot items actually right here. That will give you the list of items. And here's just a little summary of some of the functions that we'll talk about, and including, for example, you can still use the length that will give you the size or how many items are in the dictionary. Subscript operator, this allows you to retrieve the value under a key or to modify it to put on the left-hand side of the equal, the assignment operator. And you can get a key by providing a default value so that you don't have to deal with the exception. But if you do the subscript operator, if that key doesn't exist, you will get a key error exception. You can remove an item by using the pop function. And then this is how you can create a list of the keys. You may also just create a list of values or the list of items in terms of tuples. And then you can also remove all the items with a clear method. So let's take a look at the example. And the example is about printing out the unique words in a text file along with their frequencies. And here's actually an example showing also using the main function here. We'll create a main function. That's by convention, by the way. And then you're checking if the name of the module is equal to the main. If that's the case, when you're executing this program individually, that will be equal. Otherwise, it will not execute. So here we're going to get the file name from input, and we use the with statement. And you look through this input file line by line. And in each line, we're going to split it into a list of words. And then we'll look through the words to find unique words. So the unique words we're going to start out initialized as an empty dictionary. And then we're using the get method with a default value here so that we don't have to deal with the exception. So we're going to see, okay, first of all, the unique words, does it contain this word? If it does not contain this word, the frequency here will be equal to none, right? So there will be the first time we see a new word, and then we'll add this word to dictionary with a frequency 1. We've seen this once now. If we have encountered this before, then this would have retrieved the current frequency, right? And then what you do now is to update the frequency by 1 because we encountered one more time. So by doing that loop here, we've gathered all the unique words into this dictionary. Now from that unique words dictionary, we'll create a list of keys, and then we're going to sort it here. You can use the sort method on the list, but that sort method on list, remember that modify the source that is in place, it will not return anything. So this is just another way to do it. You can use the sorted function to sort that list. This will give you a new list that's sorted. And then we'll look through this list. We'll print out this. Basically, we want to print out the unique words in the proper order, alphabetically, right? So this is the key, and then from the key, we get the value, which is the frequency of that, how many times this word has occurred. So let's actually run this. And then we're going to provide the file name. Let's just say we're going to just use this program itself. This is the file itself, right? So it prints out this. This triple quotes occurred twice. Well, actually right here, right? So, and so on. It's not very pretty. It doesn't handle the special characters to separate the words because we're splitting based on spaces. So that's a simple example to use dictionary. All right, that's what I have to share. Thank you.